Bismillah Rahman Rahim. We start another practical. This is paper 3-1 and it's November 2024. November 2024. Now, as you all know, this practical is going to take place in the practical lab and you're all going to have to do it. And this is for 40 marks and the total marks is 40 and you must try to score at least 35 plus. Bismillah Rahman Rahim. Now, the first question, first of all, you must read the whole question. I'm not going to do it in the video, but I expect you in the exam to read the whole question first and then start attempting it. Think of it as a theory paper and then you'll see you'll do very well in it. Milk is sometimes contaminated with substances such as starch. You will determine the concentration of starch in a sample of contaminated milk using a range of starch standards. So there's milk and there is contamination by starch. There could be less starch or more starch or a lot of starch. You are provided with the material shown. Number 1, M is milk. SM is 1% starch solution starch milk, and that's 20 cm cube. And then CM is the contaminated milk, and iodine is the iodine solution, which is 20 cm cube. Now, one of these is an irritant. The other are not irritants. Then it says if any solution comes in contact with your skin, wash off immediately with cold water. It is recommended that you wear suitable eye protection. You will need to carry out a serial dilution of the 1% starch milk solution. 1%. This is the stock solution. SM. So this is the SM. And you have to make a serial dilution to reduce the concentration by 1/5. By 1/5. So 1% you divide it by 5. So 1.0% starch and you have to reduce it by 5. So it will be 0.2%. Right? 1 and divided by 5. So 0.2 हो जाएगा वो. You will need to prepare 4 concentrations of starch milk solution in addition to the 1% starch milk solution. You must use the milk M to dilute the starch milk solution. Do not use water for the dilution. So you have to add milk to dilute it. After the serial dilution is completed, you will need to have 8 centimeter cube of each concentration available to use. 8 centimeter. Now look at this very carefully. Complete figure 1.1 to show how you will prepare your serial dilution. Each beaker should have a labeled arrow to show the volume of starch mix solution transferred. How much are you going to transfer it? Because in serial dilution, we transfer from one to the next. A labeled arrow to show the volume of M added. Like in previous questions, we added distilled water, but here, no, we are not going to add distilled water. We're going to add M, which is the milk. M was what? M was the milk. This is the uncontaminated milk, right? So a label under the beaker to show the concentration of the starch milk solution which you have prepared. So volume of starch transferred, volume of M added, and under the beaker we show the concentration. Now you can see as it is because it was given in the question that you have to dilute it to 1/5. So from 1% it will become 0.2%. But how are you going to dilute it 5 times? So you've taken 2 centimeter of SM, 2 centimeter of the 1% starch milk solution, and you've added 8 centimeter cube of M. Now in the mark scheme it's written wrong. It's written W, but that is wrong. Because if you added water, then the white color would be diluted. So you added M, but it's given in the question, but the mark scheme is wrong. So if you're following the mark scheme, you might get this wrong. So it will be 0.2%. Now from this again, you will take out. Now out of the 0.2%, then you will take out more again. And what will you take out? Now you have to do it like this, and you keep on doing it from one to the other. Now from 0.2%, when you dilute it 5 times, it will become 0.04%. So you have again taken 2 centimeter cube of the 0.2% because this was 0.2%. And then you've added 8 centimeter cube of M. And now this will become 0.04%. 0.04, not 0.4. Please remember 0.4 is more than 0.2. I know your maths is very bad, but mine is even worse than yours. Now from 0.04, it will become 0.008. I'm sure you all have calculators and you can do it. I'm just throwing it to you because I'm used to more of mental maths. I'm not a calculator person. I hardly know how to use the calculator even. So you added 8 cm cube of m. So this keeps on going, and then you go to the last one, and that will complete this serial dilution. Now you can see the last one will be 0.0016. So 2 centimeter cube of 0.008 we have taken out, and then we've added. Now this one of course will have 10 cm cube, but out of all of them, remaining behind will be 8 cm cube, because you see you took 2 and then you added 8. So you took 2 and you added 8, so it becomes 10, but then you took out 2 again, so you're left behind with 8 cm cube. So that's what it said in the question, that it said here in the question you should have 8 cm cube of the concentration available to use. The last one will of course have 10 cm cube, but you don't have to worry about that. Now how were you given the 3 marks? Now when you look at this, I can't show you the whole of it. How was I supposed to give you marks for it? The majority of candidates got all the 3 marks. The first one was if you got the concentrations right: 0.2%, 0.04%, 0.008%, and 0.0016. Then you showed the transfer of 2 cm cube to each beaker from the previous beaker, and then you added 8 cm cube of m to each beaker, 8 centimeter cube of m to each beaker. So a very easy 3 marks, and everybody should get these 3 marks. I mean, nobody should lose any marks on this serial dilution. It would be very sad. I would be very sad. Then we read the first. Now we say carry out step 1 to step 11. Prepare the concentration of starch mix solution as shown in figure 1.1, the one we just did. Then you label test tubes with the concentration prepared in step 1. So you have 5 test tubes: 1, 2, 3, 4, and 5 test tubes. And you label them what we had in it: 1%, 0.2%, and 0.04, and 0.008, and 0.016. Put 1 centimeter of starch solution in each. So then you put the starch solution in each, and you put 1 centimeter cube of the starch into the appropriate labeled test tubes, right? And then you repeat with the remaining concentration of starch. So you have them in all the 5 test tubes. Now you add 1 centimeter of iodine. Iodine is brown in color. Now you add 1 centimeter of iodine. And what do you say? You say shake gently to mix. Now this is again a little ambiguous. Shake gently, somebody's shake gently would be different than my shake gently. Observe the color in each test tube and use the key to determine the color score. Now the color score is, you got to look at it. This is 0, and then 1, and then 2, and 3, and 4, and 5. Now this is very, very vague, because 4 and 5 to me looks the same. In fact, 3 also looks the same, and 2 is very much the same. So 0, 1, 2, yeah, but 3, 4, and 5 to me look the same. And now record the color score for each concentration of starch milk solution. Now you have to record the color score. Is it 5? Is it 4? Color score, not the color. So is it looking like this? Then it's 0. If it's looking like this, it's 1. If it's looking like this, it is 2, 3, 4, and 5. So you have to match the color, because you've added iodine, and more the starch, the more the black it will be. Lesser the starch, it will be more towards this side. So think of it theoretically, because this is what I want you to do. Think of it theoretically in these papers. Now record your results in an appropriate table. This is the table for which you're going to get 5 marks, and everybody must get their 5 marks in this table. When you're doing the table, the first rule that you do is you write the headings first. So you've written the headings first, and then you make a table around it. Right? And then you do the further. Now what you have to understand is that whatever you do is you write the units in the heading. Here of course there are no units for the color score, but there's percentage concentration. Now if you just wrote concentration of starch milk, you lose 1 mark. So now even if you've just done this table, you get 2 marks. You get 2 marks even though you've not finished the table at all. But you get 2 marks because you've written the heading for the independent variable, which is percentage count. This is the independent variable which you have decided to change. You must be very clear on the independent and the dependent variable. And then the heading for the dependent variable is the one which is the color score. So you've written that, you've written the headings, you've got 2 marks for it. Now you give the results for all the concentrations. Now you've written all the concentrations. Now, for God's sake, do not make the mistake of writing here percentage. If you do this, this is a -1. So please don't do that. Do not write units in the different columns of the table. Only and only you write the units in the heading. So do not write it in the lower part of the table. If you do that, it's a -1. Now, as you all know, the color score, the more the starch, so 1% starch will have a color score of 5 or maybe 4 even. And the color score for 0.0016 will be either 0 or 1. Because you see, there is going to be less starch. Because as the concentration of starch decreases, then the color is going to be towards this. It's going to be towards 1. Now, just thinking theoretically and writing this, you see, what were the marking scheme points? States results for all the concentrations, you got a mark for that. And correct trend for the result. The color score of 1% is higher than the color score at the lowest concentration. And you record the results using color score. Somebody might have written the color brown, black, or something like that. Now that they lose 1 mark for that. Because you were supposed to give the color score as it was mentioned in the question. So this table will get you. Now you could do it. You may not do it. You might think theoretically and just do it theoretically and give the right trend. That's fine. You will get that there's only 1 mark for that. So you will get your 5 out of 5. I'm not telling you to do something wrong, but I'm telling you to do smart work, be intelligent about it, not be a duffer. Then we come to part 3 of the question. To determine the concentration of starch in the contaminated milk (cm), you will need to test a sample of cm. State the volume of cm. Well, naturally, how much did we take of the 1% and the 0.2% and all that? So we take 1 cm cube of that. So you wrote the same you would take from here, 1 cm cube. So you add 1 cm cube of the contaminated milk, label a test tube cm, then transfer the volume of cm that you stated in A3 into test tube cm. Put 1 cm cube of iodine solution into the test tube, shake gently to mix. Observe the color in the test tube and use the key to determine the color score. So say the color score for cm was 3. Now use your results in A2, which is the previous one, and A4, which is here. Determine the concentration of starch in the contaminated milk cm. When you look at it, where was the score 3? The score 3 was at 0.04. So that's what you have to write, 0.04%. So you record the color score for contaminated milk, anything between 0 and 5. Now it says, identify one source of error in step 6. Now let's look at step 6. This is step 6. Look at step 6 again. Go back and look at step 6. Observe the color in each test tube and use the key to determine the color score. Well, you have this key here, but I mean, I'm looking at it and I don't know, this color doesn't seem very clear and it looks as if it's this color. So what is it says is difficult. So difficulty of matching the color of the test tube with the color score as a source of error. So difficulty of matching the color in the test tube to the color score, which was the color which was given on the paper. Then it says, suggest why milk is used to dilute the starch mid solution rather than water. Well, it's very basic. You see, what would have happened if that had happened? Water would dilute the color, and then we would get, a different sort of a shade. So water would dilute the color. So water would dilute the color. Then we come on to part 8 of the question. Milk is sometimes contaminated with glucose. Suggest how we would modify this investigation to determine the concentration of glucose in a sample of contaminated milk. Now, that's very easy. Use Benedict solution, heat to 80 degrees Celsius or boil it and measure the time to first color change. So, how you would determine the concentration of glucose is you use Benedict solution and heat to 80 degrees Celsius. If you just said heat and you didn't say 80 degrees Celsius, well, I won't give you a mark. And measure the time for the first color change, because if there is more glucose in it, the time for color change is shorter, it's lesser, it'll take 10 seconds. If there is less glucose, it'll take 30 seconds. So time for first color change, that's a syllabus point actually. Now coming to the B part of the question, some people are intolerant to lactose in milk. The enzyme beta galactosidase is used to break down the lactose in milk. In an investigation, equal quantities of beta-galactosidase was added to different concentrations of lactose in milk. The rate of lactose breakdown was measured and recorded. The results are shown in table 1.2. So we are talking of an enzyme. So remember, it's the enzyme chapter. So the question is on the enzymes. On the concentration of lactose, this is the independent variable. So this will go on the x-axis. The first column is always, this is the first column. The first column is always the independent variable and it goes on the x-axis. This goes on the second column is the dependent variable and it goes on the y-axis. So the first thing you do is you write the headings on the x-axis and the y-axis. So plot a graph of the data and table on the gradient figure 1.3. Use a sharp pencil. I have seen such awful diagrams with such awful thick pencils and such pathetic graphs that I feel like I will tell you what I feel like, but I can't tell you now. Label the axis with the units. Whatever the units are given, do not use any abbreviations. The units which are given to you, please write the exact units, how it was written in the paper, and you write that and you get 1 mark for all this. Now you choose the scale. Now you know on the x-axis it is concentration of lactose. So that was between 12, 42, 70, 110, 164 and 210. So what are you going to do? You got to have it right from there. You got to get it from 0 to in the end. So 210, you got to go to 240. So there's really 40 for 2 centimeter. And that is the scale given to us by Cambridge. So you decide the scale, but then you have to be sensible in deciding the scale. Don't take funny things like 20.5 or 23 or 25 or 27, something like that. That's all very weird. So you see the highest number, which is 210. So you think more than that, 240 and 40. So you got to adjust from 0 to 210 plus. So 210 plus means if you could do it to 220, well, that would be fine. But here we can't do it that. So we do 40 every 2 centimeters 40. So you label that on the x-axis and now you decide the scale on the y-axis. Now on the y-axis you have 0.30 and the highest is 1.25. So now let's decide the scale. Now you can see that I have plotted the points. The points were a little difficult to plot because it was a really difficult graph. So the points, you plot them correctly and then you have to join it, and you have to join it from the first point. You see, from the 12 point, do not extend it to 0 because there is no figure in 0. So do not extend it to 0, just connect the points which are given to you. The first point was at 12, so this was this point. So you do not connect it to 0 nor do you extend it. So we say that extrapolation, do not extrapolate. So you connect all the points and you do not, and just point to point with a ruler is the best thing that you connect. Do not draw a line of best fit when it's not asked. So please do not make these mistakes and just connect the points point to point with a ruler. That is the best way to do it. Do not extend it to 0. Do not extend it further from the points that are given to you. Now, how am I going to mark this? This is for 4 marks. X-axis labeled concentration of lactose in millimole dm cube. Y-axis rate of reaction in arbitrary units. You got 1 mark. Scale on the x-axis 40 to 2 centimeter and y-axis 0.25 to 2 centimeter. Labeled at least every 2 centimeter. Labeled at least every 2 centimeter. Many of you don't do that. Correct plotting of 6 points with cross. Either you use a cross or you use a dot and you circle the dot. Do not circle the cross. Smooth thin line join point to point through all the points. Coming to the last part of the question 1. This was for total 22 marks, this question. Describe and explain the shape of the graph. Now, description means there's no bio. So you have to describe this graph. Now, describe the graph is a simple sentence which everybody must know. I hope your English is good enough and you don't write in Urdu the answers. Rate increases as lactose concentration increases and then plateaus. Rate increases, as you can see here, rate increases and then it plateaus. So rate increases as lactose concentration increases and then plateaus. Now you have to just write that, but no, you didn't. You all are your brain fog most of the time. Gen Z is suffering from brain fog most of the time. So your brain fog takes over and you write just some rubbish and you don't get any marks for that. So description, as I've told time and time again in my videos, which I don't know, maybe you've not heard them, is that describe is no bio. So rate increases as lactose concentration increases and then plateaus. Okay, so now you have an enzyme. I told you this is the enzyme chapter. Now, as the substrate is increased, now I'm explaining it for the special Gen Z. Now, the active sites were 100. Now, the substrate was 10. And then you increase it to 100. And then you increase it to 1,000. So what is going to happen now? Rate is increases as more substrate is available. First, there were only 10 substrate. Now the substrate is increasing. So rate increases as more substrate available. And then a time comes that, all this is immaterial because all the active sites are saturated. There are only 100 active sites. So all the active sites are saturated. Now, if you understand the enzyme chapter, only then you can do this question. Otherwise, you'll just write some TR. I always write this on the papers. Total rubbish. Most of you are very good at that, sadly. So how would you word this? The description, the describe is rate increases as lactose concentration increases and then plateaus. And explanation is rate increases as more substrate available. And why does it plateau is because all the active sites are saturated. Yeah, you can say all the active sites are occupied. So all the best and thank you so much for watching.